On February 2, 2026, at 8:08:51 p.m. Eastern Time, a strange event occurred in the sky above New York City. One of the brightest stars in the night sky suddenly vanished. It did not fade. It did not dim. It didn't move. Regulus, the brightest star in the Leo constellation, and one of the 20 brightest stars visible from Earth, vanished in an instant. It reappeared 63 minutes later. This was a lunar eclipse, and for the eastern half of North America, the event on February 2 was the best opportunity to observe it in nearly a decade. That evening, there was an additional timing factor that made it unforgettable. February 2 was Groundhog Day, the midpoint of meteorological winter. The February full moon, known as the snow moon, had peaked the previous day and was still 98% illuminated, hanging brightly in the eastern sky as night fell. When observers turned their attention to the sky, Regulus appeared unusually close to the moon's bright edge. For those watching at the right moment, the star's disappearance was not a slow fade but an instantaneous cut. The star was there, then it was gone. People who had never thought about how the sky works found themselves truly bewildered. To understand why this disappearance was so sudden, you need to understand the nature of starlight from Earth's perspective. Regulus is approximately 79 light-years away, so far that even the largest telescopes on Earth cannot see it as anything other than a point of light. It has no visible disk, no angular extension, no edges it could gradually pass over. When the edge of the moon reached this point of light, the star vanished instantly. There was no transit because there was nothing to transit. This is one of the most vivid examples of how different stars and moons appear in size, despite their enormous physical difference in actual dimensions. Regulus is actually a blue-white star system many times larger than the Sun. Its apparent insignificance in our sky is entirely a result of distance. The event began differently depending on which part of North America you were watching from. Observers in Chicago and Kansas City saw Regulus disappear at approximately 7:45 p.m. local time. In Boston and Washington, D.C., the disappearance occurred just after 8:53 p.m. In Atlanta, the star disappeared around 9 p.m. In New York, the star disappeared at exactly 8:51 p.m. and reappeared at 9:54 p.m., meaning the occultation lasted a little over an hour. For observers further west, the situation was reversed. The moon rose while the occultation was already underway, and some saw only the star reappear. By the time the sky darkened in the Pacific time zone, the event was already over. Its reappearance was, in some ways, more dramatic than its disappearance. Regulus vanished behind the bright edge of the moon. This edge faced the sun and was already bright, making it difficult to look at directly. However, when it reappeared, it emerged from the dark edge of the moon, the shadowed edge not facing the sun, and was sharply visible against the deep black sky. A bright point of light framed against the dark edge of the moon, suddenly appearing out of nowhere. For observers who directed their eyes to the right place, this was described as the more striking of the two moments. Not everyone saw a total eclipse. The moon is so close to Earth that its apparent position in the sky varies slightly depending on the observer's location. This effect, called parallax, means that the moon's shadow follows a specific path across the surface. Observers within this path saw a total eclipse. Those closer to the edges witnessed a grazing eclipse, where Regulus quickly passed the edge of the moon, rapidly appearing and disappearing behind the moon's uneven edge. Observers completely outside the path saw a very close conjunction. Regulus and the moon passed within about 1 degree of each other, but no disappearance. Across the UK and Europe, the moon missed Regulus by only about 8 arc minutes, just a quarter of the moon's apparent diameter. The near miss could be seen, but the eclipse itself could not. Why Regulus in particular? Most bright stars are never eclipsed by the moon. The moon's orbit is tilted relative to the plane of Earth's orbit, so it follows a narrow strip of sky called the ecliptic region. Most stars lie well outside this band and pass by at a safe distance each month. Regulus is one of the rare exceptions. It lies almost exactly on the ecliptic, the apparent path of the sun, making it one of the few bright, naked-eye stars that the moon can actually cover. This geometric coincidence makes Regulus an ideal subject for occultation events that can be observed without special equipment. Regulus is not occulted every month. It occurs in cycles determined by the changing geometry of the moon's orbit. The current monthly series of Regulus occultations began in July 2025 and will continue until December 2026. This series of 20 events arises as the moon's orbital orientation repeatedly intersects the line of sight to Regulus from various regions of Earth. The event on February 20 was the 8th in this series. For North America in particular, this event was the best of the entire cycle. It was in the most favorable position in terms of visibility and impact. The remaining eclipses in the series will also be visible, but from different regions at different angles and with less ideal timing. For many North American observers, February 20 may be the last clear opportunity until the next series begins in 2035, approximately 9 years later. Such a long interval is significant because the eclipse cycles of bright stars are not continuous. They depend on a precise alignment between the Moon's orbital inclination, the star's position, and the geometry of the Earth-Moon star system. When this alignment occurs, eclipses happen monthly for 1 or 2 years and can be seen sequentially from different parts of the world. When the alignment changes, the same star may not be eclipsed from anywhere for nearly a decade. Regulus's cycle has a duration of approximately 9 years. Observers in North America who miss this event will not see another eclipse of this quality for most of the next 10 years. The scientific uses of eclipses are real, but their importance has diminished with the advancement of instruments. Historically, measuring the time a star disappears and reappears during an eclipse could refine measurements of the Moon's shape and orbit, reveal binary star companions that would otherwise be undetectable, and even measure the diameters of stars with high precision. In the era before large modern telescopes, these events were among the most accurate observations available to astronomers. Today, the same measurements can be made with greater precision using specialized instruments that are less dependent on weather conditions and location. However, the fundamental laws of physics remain unchanged, and the ability to observe this phenomenon without needing anything other than a clear sky and a good observation point is valuable in its own right. For observers who have witnessed this event before, the fading of a star in the moonlit winter sky is a visual moment that few astronomical experiences can match. For those who missed it, Regulus's next occultation in North America will occur on April 25, 2026, though the geometry and timing will be less favorable. After December of this year, this series will end. The Moon's orbit will change, the alignment will break, and Regulus will cease to be the target, returning to its position as a bright fixed star in the night sky. By the time North America next sees a bright star disappear behind the Moon in this way, most people watching tonight's video will be 10 years older. The sky is constantly changing. Most of this movement is invisible from night to night, too slow to be noticed against the backdrop of apparent permanence. An eclipse completely dispels this illusion. It makes the Moon's movement, relative to a star's fixed position, visible in real time at a moment you can either catch or miss. On Groundhog Day, the heart of Leo disappeared for 63 minutes.